A 1,000 kilogram car is traveling down the road at 10 meters per second. When the car begins to travel up a hill, part of the car falls off and is dragged along the hill. This dragging part exerts a force of 4,760 newtons parallel to the road. When the car is 3 meters above the ground, it is traveling at 4 meters per second. How much distance along the hill was the car part dragged? All right, so I'm solving this with energy methods, which means what I'm going to do is I'm going to look at the sum of all the energy at the beginning of my motion, the sum of all the energy wherever the question is asking about, two different locations. And in this case, I have an external force. I've got this force by this car part that's fallen off, so I'm going to have to include work in my calculations. So to begin with, I'll start with the sum of all the energy, and I'll just call it the bottom of the hill. Now, when I think about the work, I've got this displacement going in one direction, and I've got a force going in the opposite direction. Since force and displacement go in opposite directions, it's going to remove energy from the total energy that I started with. So that's going to be minus the amount of work done, and I'll just put the subscript part. That's for the car part. And that equals the total energy at the top of the hill. Top of hill. Okay, now let's define what it means to have total energy. So total energy is going to be the kinetic energy plus the gravitational potential minus the work done by the part equals, whoops, I shouldn't have done that, equals the kinetic energy at the top of the hill plus the potential at the top of the hill. Now some of these are going to go away, so to figure that out, I'll ask my questions. At the bottom of the hill, is it still moving? Yes, it's moving at 10 meters per second. At the bottom of the hill, is it above the location? No, because that's the bottom of the hill, so that's going to go away. Okay, work I'll leave alone. At the top of the hill, is it moving? When the car is 3 meters above the ground, is traveling at 4 meters per second, so yes, it's still moving. And is it higher than the other location? Yes, in fact, it's 3 meters higher, so I'll keep those energies. All right, so this defines the equation that we're going to use. 1/2 mv squared minus, let's see, did it give me the work or do I need forces? I want to know how much distance along the hill, so I'm going to have to break this up into pieces. Force times distance is equal to 1/2 mv squared plus mgh. Let's see, can I simplify this any farther? Not really. All right, now let's put in some numbers. So 1/2 the mass, that's going to be 1,000 kilograms, times the speed at the bottom of the hill. So that's 10 meters per second squared, minus the force, which is 4,760 newtons, times the distance. I'll put that in parentheses to separate it out. Equals, on the other side, 1/2 1,000 kilograms, times the velocity at the top of the hill. Let's see, that was the 4 meters per second. So 4 meters per second squared, plus 1,000 kilograms. Whoops. Put the units there. Times 9.8 meters per second squared, and the height of 3 meters. Woo, barely fit that on the screen. All right, so I'll simplify this a little bit. First, let's suppress the units since we're all in the same unit system. So this comes out to be 1/2 1,000 times 10 squared minus 4760 times d equals 1/2 1,004 squared plus 1,000 times 9.8 times 3. Okay, it looks a little bit better. Now let's figure out what our pieces are that we have in this. There are a couple things I could do. Let's just kind of keep it straightforward and simple. I'll start by looking at some of these expressions. Remember, expressions are separated by minus signs, plus signs, and equal signs. So I'm going to reduce some of my expressions. 1/2 1,000, that's 500, times 10 squared, so 10 squared is 100. 500 times 10 squared, so that's going to be 500 times 10 squared, so that's 2 more zeros, that's 50,000. Minus 4760 times d equals, let's see, 1/2 1,000, that's 500. 4 squared is 16. 500 times 15, that's going to give me 8,000 plus 1,000 times 9.8 times 3. 3 times 9.8, what's that, 28.4? 29.4. So that'll be 29400. Okay, so I got to get D all by itself. Everything that doesn't have a D on it, I'm going to move to the other side. That'll be negative, whoops, negative 4760 times D is equal to do that, what I have to do is I'm going to subtract 50,000 from the left and subtract 50,000 from the right. So when I do that, I'm going to get 8,000 plus 29,400 minus 50,000, and so that's going to give me negative 12,600. All right, now I'll divide both sides by negative 4760. So let's see, if I think about it like this, let me dress this up a little bit. I'm going to divide both sides by negative 4,760, divide by negative 4760, and then that means that D is going to be equal to 2.65 meters. So this car is only going to travel along the hill 2.65 meters.